Hello learners, today we are doing hydrolysis under acids and base. Hydrolysis is the reaction of salt and water. Salt is the product that you get when acid reacts with a base. Acid reacts with a base, that is a salt. Meaning that a salt can be a neutral salt. The salt can be acidic salt. A salt can be basic or alkaline salt. Let's start with number one. A salt of a strong acid. A salt of a strong acid and a strong base will not undergo hydrolysis. And this salt is neutral. It is neutral, meaning that pH of this salt is equal to 7. Okay. Then condition number 2, a salt that is a product of a strong acid and a weak base, okay, and a weak base, I will just say W here, a weak base will undergo hydrolysis. This salt is acidic. This salt is acidic. Its pH is less than 7. It's acidic because acid will overtake the base. Okay. Then let's say number 3, a weak acid with a strong base. Then the strong base will take over, meaning that the salt will be basic. When the salt is basic, the pH of that salt is greater than 7. Okay. So I will just list some few acids and base, but only strong. Strong acids are like the nitric acid. You must know that nitric acid is a strong acid. Then hydrochloric acid is a strong acid. Sulfuric acid is a strong acid. Let's go to the bases. A metal hydroxide. Metal hydroxide is a strong base. Hydroxide is a strong base. For example, lithium hydroxide is a strong base. Magnesium hydroxide is a strong base. So all the ions from the strong bases and strong acid will not undergo hydrolysis. No hydrolysis. So we are going to eliminate all of them. Then we are left with weak acid or weak base. Then we perform hydrolysis. If a salt is from a strong acid and a strong base, that will not undergo hydrolysis. Okay. Now let's start with number 1. Our number 1 is sodium chloride. Now if we can take sodium chloride Sodium chloride is NaCl. This is sodium chloride. Sodium is a metal, which means from strong base, that is sodium hydroxide. Cl is from HCl, which is a strong acid. This is a strong base. This is a strong acid. Meaning that this one will not undergo hydrolysis, and also this one will not undergo hydrolysis. Therefore, the salt is neutral. This salt is neutral. The pH of this salt is exactly equal to 7. Okay? Now let's look at number 2. Number 2 is sodium ethanoate. Sodium ethanoate, that is number 2. Number 2, sodium ethanoate. Sodium ethanoate is CH3COO. Sodium here. This is sodium ethanoate. Now we have these species, that is the ethanoate ion, that is CH3COO minus. Then we have the sodium here, and the sodium here would be sodium ion, that is Na plus. Now this one is from the base, which is a sodium hydroxide, which is a strong base. Therefore, hydrolysis will not take place. Space. Let's look at this one. This ion is from ethanoic acid, which is a weak acid, meaning that this one will undergo hydrolysis. Now let's perform the hydrolysis. Okay, let's perform hydrolysis. Okay, so we'll take this one because it's from a weak acid. It's from a weak acid, this one. We'll take this one, then we hydrolyze it. Then we see. But since this one is from a weak acid and this one is from a strong base, weak acid, therefore the strong base will take over, meaning that this salt is basic because the ions are from a weak acid and a strong base, which means it's basic. Salt is basic. And the pH will be greater than 7. Give a reason for your answer. Let's perform hydrolysis. Hydrolysis is a reaction of salt with water. So we'll take only the ions from a weak acid. Then we'll react them with a water. Then we get the products. Now, since there is this minus here, this one is a base in this case. This one is the acid. In fact, the ions from the acid should be a conjugate base. That is why I say this is the base. So the base will absorb or will accept the protons from water, which means we have that plus H. So we have CH3COOH. This positive, there is H plus, this positive will cancel this negative. Plus, leaving this one with only one H, therefore we have OH minus. Since the product is OH minus, the salt is basic. Then we're done with number 2. Let's look at number 3, I mean. Number 3 is ammonium chloride. ammonium chloride. The chemical formula for ammonium chloride is NH4Cl. Now, we want to know is this salt acidic or basic? First thing, we must break this salt into ions. We have ammonium ion. Ammonium ion is positive, then we have Cl minus. Now, Cl is from HCl, which is a what? A strong acid. Ammonium ion is from ammonia, which is a what? A weak base. Therefore, the strong acid will take over, meaning that ammonium chloride is acidic. The pH of the ammonium is less than 7. Now let's perform hydrolysis. We will take, or this one will not undergo hydrolysis because it's from a strong acid, strong species. Now, this one will undergo hydrolysis because it's from a weak base. Okay. Now let's perform hydrolysis and see the reason why we say this one is acidic. The first reason is that it's from weak base and a strong acid. But the perfect reasoning is the hydrolysis. Hydrolysis is the reaction of a salt with water. We take only the ions from a weak acid or a weak base. Strong acid or strong base does not undergo hydrolysis. Now, this one, because of this plus, this one is the conjugate acid, meaning that this one is a base. Now, if this one is a conjugate acid, it will donate with protons to water. It will donate with protons, that is H+, leaving this one with 3 H atoms with no plus because the plus is gone to water. So we have H3O+. Since we have the product, which is H3O+, the salt is acidic. Let's look at number 3 or number 4, ammonium nitrate. Ammonium nitrate. Ammonium nitrate is this one. Okay, if we can look here, we have what? Ammonium ion, and we have what? Nitrate ion. So this one is from a weak base. This one is from HNO3, that is strong acid. The strong acid take over. Therefore, this salt is acidic. Give a reason for your answer. The pH of it is less than 7. Give a reason for your answer. So we perform hydrolysis in that case. This, since it's a strong acid, will not undergo hydrolysis. We are left with this one. So ammonium ion plus H2O will give us ammonia plus H3O plus. Because of this, the salt is acidic. Let's look at another examples. Okay. Will the solution of the following salt acidic, alkaline, neutral? Give a reason for your answer. We done this one sodium hydroxide, this one from HCl, this one is neutral. We done this one, also did this one, done this one, done that one, so everything is fine. Same reasoning. Let's check another questions. That is the end for today's video. Please comment to the section, give a share, subscribe. You can ask questions if you have a problem. Thank you very much. I'll see you on the next video.